and Anna can see what we talked about. So let's see. Let's go to the homework.
Wait, what's the room code?
Room code for what?
Quiz. The game.
Oh, well, we're going to do that after.
Okay.
I'm glad you guys like that. We can start incorporating that into the online office hours. We could start with a fun quiz and then go over the homework or do 2 quizzes, whatever you guys like.
I like the race, how you can race each other.
You like that it was a race? Yeah, it seemed kind of fun, huh? All right, so yeah. Any questions about any part of this homework?
I do.
Anatol, okay, you want to go first?
The one thing that I got really stumped on was number 6. What is the probability of rolling the numbers 1 through 6 in order from least to greatest with a 6 rolled on a standard die? I got that one.
Okay.
Who's that?
Who was that, Kyle?
Yeah.
Okay, would you like to go over it? Or maybe Anatol, would you try to, maybe you guys can do it together? Maybe Anatol can start and Kyle can help. How about that?
Yeah, well, my way was just really simple. Yeah. I guess, what I was watching a probability video like a couple minutes ago, and what I said is if you, what I learned is that if you have like a spinner, right, or a die that has 6 sides, you roll it, you have 1/6 chance of landing one number. Like, say if you wanted to land a 1, you would have a 1/6 chance. Yeah.
That's right.
So if you do 1/6, and then you have a 1/6 chance of rolling a 2. So also on 7, the problem 7, where it says what is the probability of each of the numbers rolling 1 through 6 in any order with 6? If that's any order, I could do that one because it's just 1/6. It's 1 over 6 to the power of 6 because you have 1/6 chance of rolling one number on the die 6 times. So so the final answer.
So yeah, that is correct. Yeah. So the probability of getting a 1 on the first roll is 1/6. The probability of getting a 2 on the second roll again is 1/6. The probability of getting a 3 on the third roll is 1/6. ... and then for each one up to probability of the number 6 again is 1/6. You're gonna multiply all these, and then the probability is 1 over 6 to the 6th.
But the thing is that's for number 7. But number 6, we need another probability for it in order, right? So how could we calculate it in order?
What are you talking? Oh, hold on a second. So, this is the probability of rolling it in order.
Yeah, I know how.
The probability of rolling a die 6 times and getting each of the different numbers would be different.
Yeah, that's number 7. That's problem set 7. But what I was stuck on is problem set 6 because I know problem set 7 is pretty easy, but problem set 6 I don't know how to get it in order of probability.
I don't understand what you're saying, Michael.
I can't check my answers for number 7. Like I skipped it on check their answers website. Oh yeah, number 7 was pretty easy though. It was just it was 1 over 6 to the power of 6.
Whoa, Anatol, no. That is actually the answer for number 6.
Really?
Yes.
Wait, I thought the answer for number 6 was 1 over 6 to the power 6.
Yeah, 1 over 6 to the power 6. We just did it, right?
Yeah. Then what would 7 be?
So do you understand why that's the probability?
Yeah. Yeah, I understand that, but then how about number 7?
Because well, hold on a second. So you thought that was the answer for number 7, not number 6.
Yeah, I thought that was the number for number 7, not number 6.
You might have been confused with picking numbers out of a bag where like the number of combinations. But this is something a little bit different. So actually, the number of combinations for this problem is 1. there's only one way to roll a 1 on the first one, then a 2, then a 3, then a 4, then a 5, then a 6. Right?
Yeah.
There's only one way, and there is 1 over 6 to the 6th possible combinations of die rolls, right?
Okay. Yeah.
So another example of let's say this is the same as the probability of, let's say, getting 6 on every single roll.
That's actually one of the things.
The probability of rolling a 6 on every single roll
number 8
is
it's the first 5 times.
1 over 6 to the 6th. Oh, what's number 8?
Well, number 8 is in 6 rolls of a standard die. What is the probability that the same number will be rolled exactly 5 times?
Oh, okay. So that's yet a different problem. So here I was talking about 6 times. So we can go over all of these.
Yeah, we can go over all of them in the problem.
Let's do number 7 first, though, right?
Yeah, let's do number 7.
So okay. So first of all, we established. Let's erase this guy here. Sorry, let me go back here. I'm gonna erase that. So we established that the number of possible outcomes to rolling the die 6 times is just 6 times 6 times 6 times 6 times 6 times 6, 1 for each roll, which equals 1 over 6 to the 6th, right?
Yeah.
Yeah.
Sorry, not 1 over 6 to the 6th. 6 to the 6th. What am I talking about here? Yeah. 6 to, it's not 1 over 6 to the 6th, it's 6 to the 6th. Yeah.
This one,
So this is the number of possible number of possible outcomes, right?
So it's
in let me finish, Anatole. So number 6, there was one outcome we were interested in, so that the probability for number 6 equals 1. There's only one possible outcome that we care about, so the probability is 1 over 6 to the 6th. The numerator is 1, yes, in number 6. In number 7, the question is, what is the numerator?
Oh, I get it.
So who has an idea how to do this?
7?
Oh, shoot. I keep clicking back. All right. So the question is, what is the numerator? What is the numerator for number 7? So, who wants to approach this?
I don't know if it's correct now.
Okay. Well, so it's definitely at least 1, right?
Yeah.
Okay, so Kyle, why don't you go ahead and talk us through how you would count? So, for example, the number 6 that would count, right? For 1,
yeah.
But there's more, right? So So Kyle, why don't you take it from now? So one possible outcome is this: 3, 4. Okay, so what did you do?
I don't remember how I did it because before I was doing it. And
then... Okay.
Hold
on. So Kyle was going to say how he's going to count. So.
Well, so there were like 6 spaces.
Okay, so you have 6 different spaces,
6 like rolls. And then the first one would be like 6 out of 6 because it could be any of the numbers.
That's right. So you have, this one can be 6 out of 6, yes.
And the second one will be 5 out of 6?
Yes.
And the third one would it also be 5 out of 6?
No. So the next one would be 4.
Oh yeah, right.
So this is basically the formula for the permutations. How many permutations can we have of these 6 numbers? So that's 6 times 5 times 4 times 3 times 2
Oh.
times 1.
That's 720.
720.
Is that
It's-
720?
Yeah, 6 factorial is 720.
Okay. So we could also just write it as 6 factorial. So that's the numerator. What's the denominator?
6 to the power of 6.
Yes.
So it'd be 6 factorial over 6 to the power of 6.
Yep.
Oh, so I think it.
Okay. Yeah, I get that.
Okay. All right. So,
Yeah.
Number 8.
you guys
Oh,
want to
wait,
do
I
number
didn't
8?
get number 4 and 5.
Oh, we didn't do 4 and
Okay.
5 yet.
All right, sure. You guys want, well, so let's see. Let me see what these questions are real quick. The one nice thing about number 8, it was a continuation of this one. Do you guys want to do number 8 real quick? Is anybody confused about number 8?
I am, kind of, because I didn't really.
I did it.
I mean, I think what you can do, what I was thinking was you can do, if you want to, you would have a 1/6 chance of rolling one number, but then you would have the same chance to roll the number again.
Okay. So you're saying you have okay, so you're saying, okay, sorry, you have, what is the probability of rolling the first number?
Well, there's a 1/6 chance of rolling the first number. Or no.
Well, the first number shouldn't matter, I guess. There's different ways to count this, but
So actually, oh yeah, it has to be. It can be a random number, so there's a 6 out of 6 chance of the first number.
yeah.
Oh, I get. So
What I would do is the generally speaking and counting, the simplest thing to do is think about what is the numerator, what is the denominator, what is the number of possibilities. We know that already, right? So
Yeah.
we know the number of possibilities is 6 to the 6th.
yeah.
Right? Total
Wait, would it be 6 to the 5th?
outcomes. No, again,
I just did 1 out of 1. That's why.
we are rolling 6 die, right?
I just did it simplified. That's why I got 6 out of 6 to the power of 5.
Well, no. So there's six rolls of the die, right?
Yeah.
So the total number of outcomes is the same for all of these questions. For number 6, 7, and 8, the total number of outcomes is the same because there's 6 rolls. Okay. So you always have 6 to the 6 total outcomes. So now we want to count how many outcomes that we want exist.
So maybe.
So let's count those. Okay. So who wants to take a stab at this?
I want to do it.
Okay. All right. Let's hear it.
So the first one would be 6 out of 6.
Yeah.
Okay. Well, 6 out of. Okay. So we have. What's 6 out of 6? What does that mean?
Because it could be any number.
Okay. So we have six numbers.
That's the probability of getting the number that you want.
Well, yeah. I think what you're saying is that we could have 5 1s, 5 2s, 5 3s, 5 4s, 5 5s, and 5 6s, right?
Yeah, the first number could be any number. That's why
sure.
It's 6 out of 6.
Yeah, it could be any one of those. Yeah, so we could have, or okay, we could look at it that way too. Okay, so let's let me. So you're saying, okay, we could look at the spaces, I guess, and think about it this way. This is a little bit tricky, though. I'm not sure if this is going to end up with the right answer. But you're saying for the first spot, we could have 6 numbers.
I checked my answers, and I think I got it correct.
Okay. All right, good. So we got 6 on the first spot. And then what do we have for the second spot?
I got 1 out of 6 for the probability. Because the other one had 1 number, and then there's only 1 number. The other one has to be that 1 number, and there's 6 numbers.
Mm-hmm.
Oh, I think I got it.
Okay.
I think.
So hold on. Let's finish this thought pattern because I'm not seeing it this way. I'm seeing it a different
Well, I
way.
think what he's trying to say is like he would have the first number rolled. It can be any number because it doesn't say what number it has to be.
Sure.
So it has 100% chance of rolling any number, right?
Mm-hmm.
You can't have no number. So it would be a 6 out of 6 chance.
Yeah.
But then for the next 4 chances, it's only a 1/6 chance. So I think what he's saying is that you have to basically what it is 1/6. You have a 6/6 chance times a 1/6 to the power of 4 chance.
Okay, so you have 6 out of 6 on the first one, 1 out of 6, 1 out of 6, 1 out of 6, and what about the last one?
No. What I'm saying is, so you would have 6 out of 6 times 1 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 out of 6, which would equal 6 times 6/6. No, it would be.
What about the last roll though? What about this one?
The last roll I got 5 out of 6.
This one can be 5 out of 6. Okay.
Because
and you multiply these guys. You multiply these guys together.
Yeah. Well, yeah. You have to multiply.
30 out of 6 to the power 6.
Okay. 30 over 6 to the power 6. I'm not sure if that's right.
I gotta simplify, like 5 to the power 6 to the power 5.
So, the issue here is that it didn't say that the first 5 are the same and then the last one is different. It didn't say that. It said 5 out of the 6 are the same. So, for example, I could have a 2, a 1, a 2, a 2, a 2, and a 2.
Oh.
Right?
Yeah.
And then I could have a 2, a 2, a 1, a 2, a 2, a 2. Right?
Yeah.
Okay. So yeah, I don't think it's 30 over 6 to the 6. I think the probability is higher.
Or Tati.
So how about yes, Anko?
I guess there's 6 rolls, right? Would that mean that the first roll could be random because
I wouldn't think about it like that. The first roll being random. Again, in this type of problem, I think the best way to approach it is to think about you have 6 to the 6 total outcomes, right? That's your denominator. That's what's on the bottom, right?
Mm-hmm.
Yeah.
What's on top? How many different combinations of rolls qualify as 5 numbers the same?
I think.
So let's think about this, right? So six numbers for the numbers times 5, right?
I think
I can have 5 1s, 5 2s, 5 3s. Okay. All right.
I think,
so we need to add more to this or multiply this by more. Okay.
I said if we're looking for how many ways could it be ordered, what we can do is if it has to be same, there's the same digit. There's 5 that are the same, right? There's this one that could be any digit because it doesn't have to be the same as all of them.
Mm-hmm.
So put that digit anywhere in place, so it can be
in 6 positions. So the odd one out can be in 6 different positions, right?
Yeah. So
it can be here, 1, 5, here. 5. Okay, so there is times 6 positions.
Yeah.
For odd one out.
Mhm. Yeah, so basically it's just like it can be in 1 if it was 1 and 5.
Okay, all right. That I agree with. So there's 6 different possibilities for the number that I have 5 times, and then 6 positions for the odd one out. Is there anything left? Let me give you an example. Okay. So again, let's go to 2, 1, 2, 2, 2, 2. Sometimes it's nice to draw things out. This number qualifies, right? And the odd one out is in this position, right here, right? Right?
Oh.
What if I make this a 4? Does that still qualify? Does this qualify, guys?
Yeah.
It still qualifies, right?
Yeah.
So then the odd one out can take multiple values.
Yes.
Okay.
Oh, by the way, Touchy, do you want to share your screen so we can see like a whiteboard or something?
Oh, you guys can't see the whiteboard?
No.
Oh man, I'm so sorry. I had a whole whiteboard going the whole time.
Oh, sorry. You didn't share your screen.
Oops. Huh. Yeah, I was drawing this out the whole time. You guys didn't see it? Can you see it now?
Yeah, we can see it. Yeah.
Ah, sorry about that. Okay, that makes more sense. All right, so yeah, so I had a 1 over here, right?
This still qualifies.
This qualifies, and I can make this a 4,
Yeah.
right?
We
That
could also
qualifies.
make it a 5 and 6.
So we have 6 numbers, 6 positions for the odd one out, and then how many different numbers can this guy be?
Doesn't it have 5 positions because you can't do 2?
Pardon?
Doesn't it have to be 5 positions?
Well, let's think about it. Why do you think this? Let's go through this example. I'm sorry.
If it was a 2, then it wouldn't work.
Hold on. Sorry, I think we're getting our vocabulary mixed up here. By positions, I mean this. Let's do. Hold on. Number of possible values.
That's yeah. For the number of possible values, I would say it would be 6 because there's 6 numbers on a die. So.
Okay. Does anybody agree with that or disagree with that? What is the number of possible values for this odd one out?
I would say 6.
Okay, 6. Kyle, what do you think?
I think it's 5.
Okay, Kyle says 5. Lisa, what do you think? Or Daniel? Andrew?
I'm not sure.
You're not sure? Okay, Daniel, what do you think?
Probably 6.
6.
Yeah, 6.
Okay, let me ask this question. Can this number right here, that I'm going to erase in a second,
Hi.
can this number be a 2?
No.
Yes.
What do I have
It says
now?
exactly 5 times.
Oh, exactly. No, it can't. Oh, yeah.
So it can only be 5.
It can only be 5 because it says exactly.
If it said...
At least 5, then it
at
would
least
work.
5. Yes. Yes. Yep. And the other issue... So here's a tricky question. What about having at least 5? Would you make this
6 possible values?
Okay, but this is actually super tricky because you can't really make this because okay. So hold on, let's finish this question. So the number of possible combinations where we have exactly 5 is then 6 times 6 times 5. Does everybody see that?
Yeah. So it'd be 6 times 6 is 36. So it'd be 36 times 5. And 36
over 6 to the 6.
180?
Right?
Yeah.
So hold on, let me zoom out on this thing.
Yeah, is it 180?
180 divided by 180 out of 6 to about 6.
So it's 5 over 6 to the 4th.
5 over 6.
Okay? But if the question was at least 5, we couldn't just make this a 6. And the reason why is if this number is a 2, we would be double counting, because having a 2, 2, 2, 2, 2, 2 is the same as if the odd position out is over here, and this one's a 2. Does that make sense?
Yes.
So you can't actually count that. So if you want at least 5, it would actually be this number that we have here plus 6.
Yeah.
Okay? It wouldn't be, because if you made this one a 6, it would be 36. It's not plus 36, it's just plus 6, because we don't have 6 different positions that we could swap out.
Okay.
Okay. All right. Okay, so you guys want to go number 4, number 5?
Sure.
I did number 4.
I need number 4, number 5.
I need number 4, but I did number 5.
I need number 5, but I did number 4.
Okay. So sorry. Which one do you prefer, 4 or 5?
5.
4. I did 5 already.
Okay, so 2 4s, 2 5s. All right, let's just do both. We'll do them quick.
I need 5.
I can explain 5 if you want.
Okay.
Okay.
All right. So let me read it real quick. For a randomly selected phone number, what is the probability that the last 3 digits are the same? Okay. All right. So first, Anatol, again, what are the number of combinations?
Well, what I said.
100.
Well, there's I guess to start it off, there's 10 digits. There's 10 digits in a phone number because there's 3 digits, 4 digits,
did it say
right?
10 digit or 7
Wait,
digit?
I think I see what I got wrong.
So
10 digits, yeah.
phone
Wait,
numbers
I think
are
I
generally
see
7 digits.
Wait, I think I see what I got wrong. I need to check my answers.
But it doesn't really matter for this one.
There's
I said
1,000 combinations.
Let's pretend the number is 10 digits, 7 digits, doesn't matter.
oh well, I'm going 10 digits.
Wait, I think I got
10
it now.
digit? Okay, so what
It's
is the
just asking the last 3 digits.
yeah? What is
Well-
so? What is the total number of combinations for the
Last 3 digits.
the last 3 digits?
1,000.
The last 3 digits.
1,000.
So if you have 10 digits, oh,
Wait.
okay. Number of combinations, the last 3 digits. That's something different.
Wait, that's 100, right?
Number of combinations for the last 3 digits.
Oh, the number combination? Yeah. So,
Well, if there's
So this is
a
10
digit,
to the third, right?
but a digit in a phone number, each digit has a number 0 through 9. That is 10. You can have 10 different types of digits in a in one place of a phone number. So if there's 10 digits, you can also have 10 digits for the third to the last number, 10 digits for the second to the last number.
That's right. So you have 10 to the third, right?
Yeah, 10 to the third,
Which is
which
1,000.
is 1,000. So there's 1,000, and also
So how many? Okay, so you have. So that's actually a good denominator then. Yeah. What's not?
combination.
And then
Wait, I can't read the top. It says combinations like something 3 digits.
Last 3 digits. Sorry.
Oh, last.
Kind of messy.
Oh,
And then also, for the phone number, also, for the denominator.
This is actually a good denominator. If you, so it doesn't matter what the length of the phone number is because they don't create a condition for the first bit, right? It's
Yeah,
going to be the
but-
same if it's a 3-digit number or a 7-digit phone number or a 10-digit phone number.
Yeah, but also, Tati, if you're doing a 10-digit phone number, say if we had, if we wanted to say, you wanted the last 3 digits to be all 3, right? What we could do is, if it was a 10-digit phone number, and we wanted 3 to be the last number of the phone number, there's a 1 in 10th chance because there's 10 digits,
Mm-hmm.
and 3 could be one of the digits, or no, one of the 10 digits. Oh, but Tati, for the denominator, what I was trying to explain.
Isn't 1 out of 100? Isn't the denominator 1 out of 100? Because isn't it like the combinations for the combinations? Because it's not a 10 to the power of 3, isn't it 10 to the power of 2?
But the thing
Why
is,
would you? Hold on a second, Kyle. Kyle, is that you? Why
So
do you?
for the
Mhm.
like the beginning of like one of the 3 digits that are the same, like its probability is 100% because like the other 2 numbers have to be the same for that one, right?
Mm-hmm. Okay, so you're okay. You're approaching it differently. So you're saying the probability. So if the last 3 digits, you're saying the probability of the first one is 1. Is that what you're saying?
Yeah.
And then
Yeah.
the second one is 1/10.
Yeah.
1/10. And then the third one is 1/10.
Yeah.
Yeah, so that's one way to do it. Again, counting like this can be a little bit tricky. So I would highly recommend figuring out the denominator and the denominator first, and then the numerator. So the denominator is 10 to the third. It's 1,000. There's 1,000 different possible combinations for the last 3 digits, right?
oh, Tati.
Oh, yeah.
What if say like you're looking at the last digit numbers? There's say if we wanted to get the last 3 numbers all to be 3, there's a 1/10 for the last number. There's a 1/10 chance of it being 3, and there's also a 1/10 chance of it being in that exact place in the last one. That means that it'd be 1/10 times 1/10, so it'd be 1/100 for the last digit. But then for the second to last digit, it has a 1/10 chance of being 3, but it has a 1/9 chance of being in that same position because 3, the last position is already taken, so now we only have 9 spots left. So it'd be 1/10 times 1/9, so it'd be 190.
No, I wouldn't. I wouldn't go by multiplying these kinds of things. Again, it's more of a counting thing. Count how many different total possibilities there are and how many qualify.
Okay.
Yeah, not number like yeah. Here the position is not as relevant. Again, we found the denominator already. It's 1,000. That's our denominator.
Okay.
Yeah.
Right.
It's on the denominator. Yeah, 1,000.
So we have 1,000 different possibilities for the last 3 digits. How many qualify for our condition? Does 111 qualify?
Yes.
Does
Yes.
222 qualify?
Oh wait, so those 10 of them qualify? 10
That's
of them?
right.
000.
000 qualifies.
Yep.
And then it goes 0, 1, 1, 2, 3, 4.
Until 999, which would be 10 of them.
Yep. So is there any other qualifying last 3 digits?
No.
That's it, right?
Yep.
Yeah.
Yeah.
So there's 10. So then
Wait.
the answer is 1
But then I got
over
the same answer. I got 1 out of 100, and that didn't work.
1 over 100. That should be the answer. Let me read
It
the
said it
question
was
again.
wrong.
Maybe I put it in wrong. I maybe had a wait. Let's see, number 5.
Yeah, number 5.
Yeah, it's 1 out of 100. That would be correct. Maybe I copied it wrong. Yeah.
Okay, I got it correct then.
Okay, then could we do number 4?
Okay,
I
let's do number
didn't-
4.
Didn't get number 4.
Yeah, number 4 I couldn't get.
Okay. 6 students stand in a line. What is the probability that from left to right they are standing in order from oldest to youngest? Interesting question. So who wants to take a stab at this one? So I have 6 students. Let's call them 1, 2, 3, 4, 5, 6. Okay. So, what is the denominator in this question? So I have 6 students. How many different ways can I order them?
You can order them 720 times. 720 ways.
Yeah.
Okay, so
Because 6 factorial is 720.
Yeah, 720 is 6 factorial.
equals 6 factorial.
Which is 720.
Sure, 720. So there's 720 different ways we could order these 6 students.
But we want a left to right. That's one of the important. And they want it from oldest to youngest. So the top left would be top left would be the oldest, and the top right would be the youngest.
Only one way would work out of 720 ways.
Yeah, only one way, right?
Yeah.
So that would be 1 over 720.
Yes. There is a caveat to this, though. That this is correct. 1 out of 720. What if 2 students have the same age? 2 students can have the same age.
Wait.
Then
multiple-
two ways would work.
If 2
Then
students
two
could
ways
have the
would
same
work out of
age.
720.
And then 2 ways would work.
Then they would be next to each other.
So it would be 2 ways.
2 ways.
Yes.
Because
Okay.
you can switch them.
You could switch them. That's true. You could switch them. So is it 2 over 720?
Oh.
Well, it should be 1.
Well, I could have it, so let's pretend these are the ages right here, right? I could have it that 2 of the students are age 2, right?
Yeah.
But I could also have it that 2 of the students are age 4.
Yeah.
Right? So that if 2 of the students have the same age, it's not just 2. There's more. It's actually 2 because they could be in the first and second position, plus 2 because they could be in the second, third position, plus 2 because they could be in the third and fourth position, plus 2 because they could be in the hold on. Oh, there's another 2 in here. Yeah. So there's actually 10 different ways you could order them if they could have the same age. In this question, I think that you could just assume that they're going to have different ages.
Yeah.
Because that would make it a lot more complicated. Because then you could have 3, etc. But yeah, 1 out of 720. That sounds right.
I think that's I think everybody else, all the other ones
Is that
are.
it? You guys want to do one quick quiz for the end?
Yeah.
Wait. What was the answer in all then?
Oh, 1 out of 720.
Wait, I tried that and it didn't work.
It didn't work?
Yeah, I tried 1 out of 720.
Let me read the question again just to make sure. 6 students in line was the probability that from left to right they're standing in order from oldest to youngest. Yeah, it should be 1 out of 720 because there's only one way that they could stand like that. So I have to check. Maybe I kind of put in the answers kind of quickly. Maybe I mixed some of them up.
I want to do a quiz.
I'll double check those. You guys want to do a quiz?
Yeah.
All right, let's do a quiz. So let me cancel the live stream or stop the recording.